Good morning, my dear students. Today I am going to discuss the topic that is called increasing and decreasing function. In the last class, we have discussed about the definitions as well as concept behind this particular topic. When the function is increasing, how calculus can be introduced here. So everything we have discussed in the last class. So using this all concept, today we are going to solve few problems in this particular topic. Before starting the topic, I just give a little idea about a very small concept that is called how to solve the inequations. How to find the solution set of an inequations. We know that how to find the solution of an equations, and let us discuss about how to find the solution set of an inequations. We know that suppose that x minus 1 into x minus 2 suppose is equal to 0. This is an equations. If you solve this equation, then you will get x is equal to what? 1 or 2. X is equal to what? 1 or 2. Okay. This is the solution of this particular. This is a quadratic equation. This is an equation, and if suppose that x minus 1 into x minus 2 is greater than equal than 0, or greater than 0 or less than 0, whatever be, it represents an inequations. So it has an infinite number of solutions. How to find the solution set of this particular equations? So if you put x is equal to 1 and x is equal to 2, then you are getting what exactly? It is equal to what? 0. So that x is equal to 1 and x is equal to 2 for these inequations, you can say it is it representing a curve, right? It representing x minus 1 into x minus 2 representing a curve. And for these inequations, x is equal to 1 and x is equal to 2 are called critical points. From here what happen? The function maybe start to decrease or maybe start to increase. So these point x is equal to 1 and 2 are called what? There is a critical points. And since this is a polynomial function, if you square, then it is a quadratic polynomial. So polynomial function have that is domain is the set of real numbers. So here if the domain consider is what? This is your domain minus infinity to what? Plus infinity. And the critical points are, that is 1, this is what? 2. Okay. So your solution will be within this domain. It is a part of the domain, it may be a whole domain. Okay. Now we consider our target is that it is greater than and equal than 0. Equal than 0 when this is x is equal to 2 and equal to 1, then it becomes what? Equal to, when x is equal to 1, it becomes what? Equal to 0. Okay, equality satisfied. Clear? Now if you consider a point greater than 2, suppose if you consider 3, x is equal to 3 somewhere else, so हमें ले लीजिए x is equal to 3. If you put x is equal to 3 here, then 3 minus 1 it is positive and 3 minus 2 it is positive. So ultimately condition satisfied, greater than 0 condition is satisfied. Okay. So our that particular expression x minus 1 into x minus 2 is positive in this part 2 to infinity. Okay. Now consider a point between 1 and 2. Suppose we consider 1.5. Consider a point 1.5. If we put 1.5 here, then it is positive. If you put 1.5 here, 1.5 minus 2, it is negative. So positive into negative is equal to what? Negative. Ultimately our expression, this expression is what? Negative within this interval. Okay, it is negative. Okay. Now take a point in this particular part. Okay, less than 1. Less than 1 you consider a point, suppose minus, suppose you can say 0. Put 0 here. Less than 1, a number is 0 also. 0 minus 1 is negative. 0 minus 1 is negative. Ultimately negative into negative is equal to what? Positive. Negative into negative is equal to what? Positive. So ultimately your expression this positive. Since we need greater than equal than, is need greater than equal than what? 0. Okay. We need what? This expression greater than equal than 0. So where it is positive, we consider in this part it is positive and in this part it is positive. So in this part it is what? Negative. So we will not consider this part. Okay. What are the value of x? Okay. Value of x belongs to minus infinity to 1. Minus infinity to 1. Minus infinity is always open and here we consider this is closed. Why closed? Because for x is equal to 1 it is equal to 0, satisfied. That's why what happened, we consider it is closed. Union, this part 2 to infinity, this part is open and this part is closed. Why closed? When x is equal to 2, again this particular inequation is satisfied. So ultimately what happened, x minus 1 into x minus 2 greater than equal to 0 when x belongs to this union this, or you can say when x is less than 1 or x is greater than 2 and equality is there, so we are taking equalities. Okay, so this is the solution set. If say suppose it is strictly greater than 0, it is strictly greater than 0, what will happen? It is strictly greater than 0, then what will happen? We will not consider the point, because for x is equal to 1 it is equal to 0 and this condition is what? Strictly greater than 0. Therefore we are excluding. We can make this and what? Open circle. Is what? Open circle means we are not taking the point 1 and 2. So solution set will be what? Solution set will be what? This one. Solution set will be this one. That means x is less than 1 or x is greater than 1. Or means what? Or means what? Union. X less than 1 means minus infinity to 1. X greater than 2 means 2 to infinity. And or means what? Union. Okay. In this way we can find the solution set of an inequations. And this method is called what? Wavy curve method. And here you see curve is this way. Positive, then negative, then positive. You can say like that. Okay. Suppose that I am taking another particular expression, 1 minus x into 2 plus x, what? Greater than 0. Suppose that. Now, here you see in this particular expression, the before x there is a positive sign and the coefficient of x should be what? 1. Here the coefficient of x is equal to what? Minus. So, we have to make it positive. How to make it positive? We have to make it positive by multiplying by minus 1. Then it becomes what? X minus 1 and it is already x plus 2. Okay. It is already what? X plus 2. And since I am multiplying an inequation, we know that if you multiplied an inequation by a negative sign, then what happened? Sign will be changed. For suppose that 3 greater than 2, if you multiplied by minus 1, what happened? Minus 3 less than minus 2. So sign will be changed. Similarly here multiplying by minus 1 means sign is changed. Sign is what? Changed. Now if you make it is equal to 0, the what are the critical points? Critical points are 1 and minus 2. Critical points are what? 1 and minus 2. Now plot this critical point on the number line, because the domain of this expression, domain of this is a polynomial function. So domain of this expression is what? Is real number. Okay, it is a function. So the function, domain of the function is set of real number. So this is your domain, minus infinity to what? Plus infinity. And what are the critical point? 1 and minus 2. So minus 2 is there and plus 1 is there. Okay. Now if you plot a point greater than 1, suppose इसमें आप 2 पुट कर लिया, 2 पुट कर लिया. Suppose if we put here 2 minus 1 क्या होगा? Positive. 2 plus 2 क्या होगा? Positive. तो रिजल्ट क्या आ रहा है? Positive आ रहा है कि नहीं? तो then you put a number between minus 2 and 1 के बीच एक नंबर है suppose 0. Take a number a simple one, 0. So 0 minus 1 क्या होगा? Negative. minus 1 हो रहा है. 0 plus 2 क्या हो रहा है? Positive. दोनों को multiply करो क्या हो रहा है? Negative into positive is equal to what? Negative into positive is equal to what? Negative. So this symbol is negative. Okay. And again take a number less than minus 2. Suppose minus 3. Okay. Minus 3 is a number. Minus 3 is a number less than minus 2. You take a minus 2 here. Minus 2 minus 1. Minus 3. Okay. Minus 3 minus 1 means minus 4. So it is what? It is what? Negative. Minus 3 plus 2. It is what? Again negative. So negative into negative is equal to what? Positive. So this symbol is positive. So for such type of expression, quadratic, if it is factorized, okay, linear factor, in terms of a linear factor, then what will happen? You will start by right number, जो आप number line में put करेंगे, right से क्या शुरू करेंगे? Positive, then negative, then, and here you see power of this expression are all what? Odd number. अगर odd number हो जाए power अगर odd number हो जाए तो आप क्या करेंगे? तो पहले positive लिखेंगे, then negative, then positive. Very easy. Then what is the solution set? आपका क्या चाहिए? Negative चाहिए. This is less than 0, right? Your expression is what? Finally what? Less than 0. Okay. you are getting this expression which is less than 0. So less than 0 कहाँ मिल रहा है, नेगेटिव कहाँ हो रहा है, एक्सप्रेशन वहाँ हो रहा है. सो आप क्या करेंगे, उसका सोल्यूशन सेट x बिलोंग्स टू व्हाट, -2 to 1. And this is open interval because what happened, there is no equality. So this is an open ball, this is an open ball. वहाँ में क्या होगा, ओपन सर्कुल हो जाएगी, क्लोज सर्कुल नहीं होगा. ठीक है. तो फाइनली what happened, your solution set will be x belongs to -2 1. So this method is called wavy curve method. ऐसा होगा positive then negative then positive, wavy curve method. This method is to find the solution set of an inequation. It is very short trick. If you utilize this short trick, and that short trick is called wavy curve method. Okay, so I hope you understand. This is required in your this particular chapter to find the interval where the function is increasing or where the function is decreasing, where the function is strictly increasing and where the function is strictly decreasing. That's you need to do in this particular chapter. Okay, so let us start a problem and apply it, then you will enjoy. Okay, first question. A simple question I am going to take. Question is find the intervals in which the function f given by fx equal to 2x cube minus 3x square minus 36x minus 7 is number A strictly increasing and number B strictly decreasing. So you have to find the interval where the function is strictly increasing and where the function is strictly decreasing. Okay, so to know the function is strictly increasing or strictly decreasing, one particular concept is you have to find the f dash x. So your given function is what, fx equal to 2x cube minus 3x square minus 30x minus 7. This is your function. Okay, if you derive it, you will get f dash x equal to 6x square, 6x square minus 6x minus 36, or you take common 6, you will get x square minus x minus 6, and if you factorize it, very simple, minus x can be written as what, minus 3 plus 2. So what will be the x minus 3 into x plus 2 will be the ultimate factorization of this particular expression. Okay, ultimate factorization of this particular expression. Clear everybody? So x square minus 3 plus 2 minus x minus 3 into 2 minus 6. Okay, clear? Now we are going to show that this function is where the function is strictly increasing. Your original function is a polynomial function. So domain of the polynomial function is the set of real numbers. Set of what? Real numbers. Okay. Now you put f dash x, the rule is you have to put f dash x equal to 0 first. And after putting f dash x is equal to 0, you have to find what? Critical points. You have to find what? Critical points. Okay. Your main objective is to find what? Critical points. F dash x equal to 0 implies 6 into x minus 3 into x plus 2 equal to what? 0. From here you can write x is equal to 3 comma minus 2. X is equal to what? 3 comma minus 2. Now these 3 comma minus 2 are 2 points where the graph of the function going to shift. into increasing or into decreasing. So these 2 points are called critical points. These 2 points are called critical points. Okay. Now this particular critical point divide our whole domain into how many parts? That's very important. How many parts? You see, if I draw the number line, you draw this number line, okay? Minus infinity to plus infinity. Suppose this is the number line. Minus infinity to plus infinity. Okay? And the critical points are minus 2 will be the left, and then this is 3. Okay? Ultimately, this minus 2 and 3 divide our intervals. Divide our intervals into how many parts? 3 parts. This is one part, this is second part, and this is what? Third part. 3 disjoint parts. I am to say 3 disjoint, but excluding the critical points. So 3 disjoint part. What are the disjoint part? One part is from here to here, and this. These are the 3 disjoint parts. So we are going to check that whether our function increasing, where it is increasing. Here it is strictly increasing, or in here or here. We will check in all the 3 cases, right? Clear? So you have to write a sentence here. These points divide the real line, because real line, the set of real numbers, representing the set of real numbers is called real line, into 3 disjoint intervals. First interval is minus infinity to 2 and minus 2 to 3 and 3 to infinity. All are disjoint. Okay, all are. You see, you take this intersection, there is no common point. You take this intersection between them, there is no common point. Or you take the intersection between this and this, you will get what? No common point. Therefore this is called what? There is a particular 3 intervals are called disjoint interval. These 3 disjoint interval divide the whole real line into 3 parts. Okay. Now for fx to be strictly increasing, for fx to be strictly increasing, what is the condition? F dash x must be greater than 0. F dash x must be greater than 0. F dash x means what? 6 into x minus 3 into x plus 2 greater than 0. We know that 6 is always positive. We do not know about what is x minus 3 and what is x minus 2 actually. Whether it is positive or negative, where it is positive, where it is negative. Clear everybody? Now from here we are going to find the value of x where f dash x greater than 0, and that x will represent the interval where the function is increasing or decreasing, strictly increasing or strictly decreasing. Now go to the wavy curve method again. Use this wavy curve method here. There is minus infinity to plus infinity. Okay. From here you see this is your 2 minus 2 and this is your 3. We know that for such a factorization where every factor is a linear factor, then we will start with what? Right से हम शुरू करेंगे पॉजिटिव से. तो ये पॉजिटिव होगा, ये नेगेटिव होगा, ये पॉजिटिव होगा ऑटोमेटिकली. No need to check. Earlier I have given an example putting the value of this and show you that yes, here it is positive, here it is negative, here it is what? Again positive. But in such a, whenever you get such expression, you write like that without any hesitations, Now your expression should be greater than 0, right? So greater than 0 कहाँ मिल रहा है? You are getting here and here, so you have to exclude that. Therefore from here you can write, therefore which implies, therefore x is, यहाँ से क्या हमारा wavy curve method से क्या आ रहा है? When x is greater than 3, जब 3 वहाँ से बड़ा वाला में क्या हो रहा है? पॉजिटिव हो रहा है, और x is less than minus 2, that means this part or that part, our expression is satisfied. That means f dash x is greater than 0. That means f dash x is greater than 0 when x is greater than 3 or x is less than what? Minus 2. And f dash x is greater than 0 means fx is strictly increasing in the interval. Where the interval? This interval and that interval. So you can conclude that therefore f dash x fx therefore fx is strictly increasing. Fx is strictly increasing in the interval. What is the in what? In what? The interval in what? This x greater than 3 means what? In 3 to infinity or union. Or means what? Union. X less than minus 2. X less than minus 2 means what? Minus 2 से शुरू होकर minus infinity. Equality is not there, that's why minus 2 is excluded here. Okay, minus infinity to what? Minus 2. This is also open. This is also what? Open. So finally what we get? Our function fx is strictly increasing. F dash x greater than this inequality is satisfied only when x greater than 3 or x less than minus 2. And this x greater than 3 or x less than minus 2 representing the intervals where f dash x is what? Greater than 0. That means fx is strictly increasing in these intervals. Okay. Now you can say again fx is strictly decreasing. Fx is strictly decreasing when f dash x is less than 0. In the earlier class we have discussed that when the slope of the tangent, f dash x means what? Slope of the tangent at any point to the curve is negative. That means slope makes an angle what? Obtuse angle with the positive direction of what? X-axis. Then we can say that the function is what? Decreasing, strictly decreasing. Okay. So f dash x less than 0 implies 6 into x minus 3 into x plus 2 less than 0. 6 तो नीचे जाएगा तो ये ख़त्म हो जाएगी. तो you write x minus 3 into x plus 2 less than 0. Okay. Again you draw the number line. Here minus infinity to plus infinity. Okay. Your critical point is what? This is minus 2 and this is what? 3. Okay, understood? Now again the sign utilized positive, negative, positive as per our norms. Okay. Now where is your function is negative within this interval? F dash x less than 0 कहाँ हो रहा है? F dash x means ये है. ये कहाँ less than 0 हो रहा है? This interval में. That is implies x is what? Minus 2. X कहाँ है? उसके अंदर है. That means minus 2 less than x less than 3. उसमें x का जितना वैल्यू है सब वैल्यू के लिए क्या हो रहा है? ये नेगेटिव बन रहा है minus 2 से 3 तक. वहाँ में एक वैल्यू, यहाँ में एक वैल्यू, जहाँ से जितना वैल्यू सब वैल्यू पुट करके आप एक बार टेस्ट कर सकते हो. You can find out 2-3 points between minus 2 and 3 and you have to check yourself. 0 पुट कर सकते हो, 1 पुट कर सकते हो या 1.5 पुट कर सकते हो करके देखो नेगेटिव मिलेगा. क्या मिलेगा? ये एफ डैश एक्स नेगेटिव हो जाएगी, लेस देन 0 हो जाएगी. दैट मीन एफ डैश एक्स लेस देन 0 मीन्स एफ एक्स इज स्ट्रिक्टली डिक्रीजिंग. एंड व्हेन एफ एक्स इज स्ट्रिक्टली डिक्रीजिंग then what is the condition on x? X lying between what? Minus 2 to 3. And why not close? Because of the strictness. Okay, strict, that is the strict inequality. So from here therefore x is belongs to minus 2 to 3. This is the interval. So you can conclude that. What is the final conclusion? Your final conclusion will be fx is strictly decreasing. The fx is strictly decreasing in इंटरवल क्या है -2 to -2 to 3। सो हो गया, कहाँ कहाँ फंक्शन इंक्रीजिंग हो रहा है, कहाँ कहाँ फंक्शन डिक्रीजिंग हो रहा है, ये आपको देखना है। ओके, सो दिस इज द वे यू कैन फाइंड आउट द इंटरवल वेयर द फंक्शन इज थ्रू आउट द domain should be split according to the critical points, and after finding the critical point you have to check in which interval the function is positive and that f dash x is positive, and in which interval f dash x is what, negative. And if you do like that, then you can easily find the interval where the function is increasing and decreasing. So I hope you understand. So nice questions and very interesting. So you develop this skill how to solve an inequations by Webby-Curve method. Webby-Curve method means yes, positive negative ऐसा होगा. So there are extensive rule of there is Webby-Curve methods are also there, and coming days and gradually I will discuss all these points. Okay, now let us solve another questions related to this particular topic. The question is, show that, important question, show that y equal to log of 1 plus x minus twice x by 1 plus x 2 plus x, where x is greater than -1, is an increasing function of x throughout its domain. Okay, you have to show that it is an what, increasing function. Okay, increasing function means you have to show that dy by dx is what, greater than equal than 0. Function is y, right? Dy by dx is greater than equal than 0 for all x greater than -1. Domain is what, here it is given, domain is what, greater than what, -1. -1 नहीं है, लेकिन -1 से थोड़ा सा बड़ा नंबर से डोमेन शुरू हुआ है. So whole domain what, function is an increasing function. It means you have to show that dy by dx is greater than equal than 0. So you have to find dy by dx to understand the problems or solve the problem. Dy by dx equal to ddx of log 1 plus x minus ddx of twice x by 2 plus x. This is your, that is derivative. You are going to find that ddx of log x means what, 1 by x. So हमें क्या होगा, 1 by 1 plus x, and again derivative of 1 plus x. 1 plus x का derivative क्या होगा, ddx of 1 is 0 and ddx of x is equal to what, 1. So ultimately ये क्या होगा, 1 होगा, 0 plus 1. So no need to write, minus this is ddx of u by b format. So here you utilize this Quotient rule of differentiation. 2 plus x, फॉर्मूला क्या था, नीचे वाला जो है उसको स्क्वायर करना है, और शुरू करेंगे नीचे वाला से, 2 plus x इंटू ddx of twice x. ओके, एक बार कर लेता हूँ, ddx of what, twice x प्लस माइनस, फिर क्या होगा, माइनस twice x इंटू ddx of 2 plus x. व्हाट फॉर्मूला आई एम अप्लाइंग, u by b, b स्क्वायर, नीचे क्या होगा, b स्क्वायर, स्टार्ट ऑफ b इंटू ddx of u माइनस u इंटू ddx of what, b. सो the calculation is at 1 by 1 plus x minus 2 plus x whole square. Here ddx of twice x, 2 बाहर आएगी, 2 बाहर आ जाएगी, ddx of x क्या होगा, 1 होगा, तो 2 होगा. 2 इंटू दिस कितना हो रहा है 4 प्लस 2x, मैं डायरेक्ट कर रहा हूँ। एंड इसमें क्या हो रहा है डी डी एक्स ऑफ 2 इज़ व्हाट 0 एंड डी डी एक्स ऑफ x इज इक्वल टू व्हाट 1, अल्टीमेटली 1 होगा, 1 इंटू ट्वाइस एक्स क्या होगा ट्वाइस एक्स, सो दिस वन एंड दैट वन कैंसल, क्लियर। देन टेक एलसीएम बिटवीन दिस टू, LCM will be 1 plus x into 2 plus x whole square, okay. After taking LCM it will be 2 plus x whole square minus, याद इधर क्या होगा 4 रहेगा, बाकी तो कैंसिल हो जाएगी, 4 into 1 plus x, okay. Then you can just need calculations. Denominator and numerator को थोड़ा सा कैलकुलेशन करो, denominator नहीं चाहिए, denominator will remain as same. So ultimately dy by dx equal to, the denominator becomes what 1 plus x into 2 plus x whole square, okay. And numerator becomes थोड़ा सा एक्सप्रेशन को फॉर्मूला एक्सपांड करो, 4 plus 4x plus x square minus 4 minus 4x, this one cancel with this one cancel with this, and finally we are getting x square by 1 plus x into 2 plus x whole square, okay. What is your domain now? Very very interesting. Domain is what this is, minus 1 to infinity. Greater than 1 means what? Greater than minus 1 means what? minus 1 से शुरू होके पॉजिटिव इन्फिनिटी तक उसका क्या है डोमेन है, उसमें भी ज़ीरो भी है, ओके। इफ़ यू स्क्वायरिंग द नंबर फ्रॉम -1 to 0, नेगेटिव नंबर को स्क्वायर किया जाए तो क्या होगा पॉजिटिव हो जाएगी, और जीरो को स्क्वायर किया जाए तो क्या होगा ज़ीरो हो जाएगा। दैट मीन्स फ्रॉम हियर -1 to 0 x square is greater than equal than 0, x square is greater than equal than 0, and whatever be the x greater than 0 for this, x square is always greater than, strictly greater than 0. That means what we get from -1 to infinity, whatever be the x, for every x if you square this, all this real number, because these are all real numbers, if you square it then you are getting what x square is greater than equal than 0. दोनों को combine करें तो क्या हो रहा है, x square is greater than equal than 0 हो रहा है, understood. That means when x is greater than -1 implies x square is always greater than equal than 0. Very interesting concept. So you have to understand it. Again you see x is greater than what -1 implies, ये -1 इधर ले आए तो क्या होगा x plus 1 is positive. X plus 1 is positive. If x plus 1 is positive, very interesting is that x plus 2 is also positive, yes or no? How to get x plus 2? X plus 2 means again add 1, then it will be x plus 2 greater than 1. दोनों साइड में हम 1 ऐड कर लेंगे तो 1 is also greater than 0. So finally what we get, for x greater than -1, x square is greater than equal than 0, x plus 1 is strictly greater than 0, and x plus 2 is also strictly greater than 0, yes or no? So from few things you have to write here, you have to write like that, since x greater than -1 implies this, x square greater than 0, x plus 1 strictly greater than 0, x plus 2 strictly greater than 0. You have to write this, okay. For x greater than -1, this condition are satisfied. If it is strictly greater than 0, it is strictly greater than 0, then both are positive, strictly positive number, like suppose 2 and 3. 2 and 3 are strictly greater than 0, right? Then उसको प्रोडक्ट करेंगे क्या होगा 6 होगा, तो 6 is also greater than 0. So if you multiply this two particular term, x plus 1 into x plus 2, what will happen? It will be also positive. So implies x plus 1 into x plus 2 is greater than 0. Now numerator is greater than and equal than 0 and denominator is strictly greater than 0. तो दोनों को अगर मैं एक साथ यूटिलाइज करूँ तो इसमें क्या होगा, which is greater than equal than, which is greater than equal than. Why equality is there? Because for some value x equal to 0 क्या हो रहा है, ये टर्म क्या हो रहा है 0 हो रहा है, 0 by anything positive, ये तो पूरा पॉजिटिव है, तो 0 डिवाइड बाई पॉजिटिव वर्ड 0 भी हो रहा है तो इक्वलिटी भी आएगा और स्ट्रिक्टनेस स्ट्रिक्टली ग्रेटर देन 0 दोनों आएगी, ठीक है. तो ग्रेटर देन इक्वल देन 0 फॉर ऑल एक्स बिलोंग्स टू 1 to minus 1 to infinity. ये ओपन है because of strictly greater than. Understood? Ultimately what happens, dy by dx is greater than equal than 0 for all x belongs to that domain, and which means y is an increasing function throughout its domain. Therefore you can say that therefore y is an increasing function throughout its domain. So this is the way you have to solve the problem.